In today's video, I'm going to be covering Shallan50K's May 2021 Commodore 64 Coding Challenge. Shallan is now hosting monthly coding challenges, including Mega 65 game challenges, which have resulted in some amazing new content for the upcoming console. This is the third Commodore 64 challenge and the second one I have participated in. The first one involved creating a spiral in the shortest code possible. In the May challenge, the aim is to write an efficient function to correctly display 3 letters or numbers from the default Commodore 64 uppercase ROM font, but magnified 8 times and include a shadow. This time, the winning entry was to be based on not only the shortest program code, but also the fewest number of cycles. What Shallan was doing was multiplying the program size by the number of cycles it takes for the program to finish executing and calling it the MCB or KCB, megacycle bytes or kilocycle bytes, depending upon how large it is. He supplied the demo code, which properly calculates the cycle count based on your submission. The entry with the lowest byte count multiplied by the cycle count will be declared the winner. There were a total of 14 entries, including mine. The top 5 entries were really close, nearly a photo finish. I'll quickly cover the posted rules for this challenge. Each character must be made up of inverse spaces in white corresponding to the exact pixels in the ROM font, with a drop shadow down and to the right made of inverted spaces char160 in black. The first character must be displayed starting at x equal to 0, y equal to 9, which is 568 on the screen. The second at x equal to 10, y equal to 9, which is 572 on the screen. And the third at x equal 20, y equals 9, or 57c on the screen. The main program will call the method at C000 with the character values to be displayed found at addresses 2, 3, and 4 in that order. All program code and tables must reside between C000 and CFFF. Screen RAM will remain at the default of 400 and must not be changed. All 0 pages free for variable usage as basic and kernel are banked out. The function must be able to be called multiple times, so any self-modified code must set itself up. Before I take a look at the competitor's code, I'll quickly cover my thought process and algorithm and a few early programs leading up to my submission. I will discuss the mistakes and oversights I made which cost me dearly. Even though I placed last in this month's competition, I had a blast attempting to compete and trying my best to solve the problem in the best way I could. Had I spent a little more time analyzing even my own solution, I'm sure I could have easily squeezed another 50 or so bytes out of my solution, perhaps maybe even squeezing down under 100 bytes. However, all that is hindsight. I learned a few more techniques and cheats that I will most likely never use, but it was interesting. I plan on interviewing the old school coder to talk about his solution, so stay tuned for that in an upcoming video. Before I go into showing my program code, and I'm only going to show 2 versions of my code since my entry was last place, it's probably not of great interest to most people. But I wanted to try to explain the basic overall algorithm in order to solve this month's submission. And if you go into CBM Program Studio, which is what I've done here, and I've opened up the character editor, here we can easily shift left and right. And if you look at each byte of a character, each character is made up of 8 bytes. The top line is 1 byte, the second row, I guess, is the second byte, third byte, fourth byte, all the way down. And if you notice, most characters don't use that bottom byte. So that's something you have to take into account when you're doing this challenge. So now, if you're looking at a specific row and you want to figure out what these individual bits are on the first byte, which is the first column, the first row at the top, you can load the byte in and shift it right. And that shifts over the first bit over into the carry. And the carry that you can then check if it's 0 or 1. If it's 0, you don't have to necessarily draw that character on the screen. You can skip to the next position. And then you can shift it again If it's 0, you can, so we go back left here. Then we can shift it again. We got another 0. Then we shift it again. We get a 1, 1, 1, 1, 0, 0. So you see, by shifting the characters, you can figure out what those individual bits are and make decisions based on that. So on the challenge, I'm going to bring in the screen editor from CBM Program Studio. And I'm going to mark the positions that I mentioned earlier in this video. So I've marked the starting positions here at 568, 572, and 57C. And this is where all the characters were to be drawn, which are exactly 10 bytes, separated by 10 bytes. So if you kind of mix that in with the character editor, if you were going to draw this, you're going to have to come up with an algorithm to draw it. And if, let's just say this top line is blank, blank, 4, 1, 2, 3, 4 inverse spaces, and then blank, blank. So you would kind of go 1, 2, 1, 2, 3, 4, right? Just for that top line. Now, the shadow, you want to go over 1 and down 1, and then draw the shadow 1, 2, 3, 4, but this shadow would be in a different color. Oops, right here. And so you can do those simultaneously, and that seemed to be the algorithm that most people were using, was to draw these two at the same time, basically adding decimal 41 to this and to draw the shadow when you do. So I'm going to do the rest in fast motion, sped up. That's the process, one character, if you just were to do one character. But depending upon your algorithm, you'll probably want to do this top line, then come over to this position, do this top line of the next character, come over to here, do this top line. So you're doing the whole line one at a time. But that's the general idea of the algorithm. And then your program has to be written in such a way that when you call it a second time, it can run a second time. So if you have any self-modified code, it has to be reset. So that's the algorithm. Now let's take a look at the program code that I started with. All right, this was my very first attempt, and before doing anything else, all I was doing was essentially implementing the algorithm I just spoke of, but I started with characters that I drew right here, not actually taken out of the character set. And when you run it, it was just characters I drew randomly. And that was kind of a proof of concept, just to see, oh, okay, here you draw one character this way, another character this way. And I kind of drew them out. You can kind of see the zeros and ones here in binary. So it was very simple and short. This one was only 78 in size. And you see I didn't have any colors and I don't have any shadow at this point. So then, of course, I just skipping them way ahead to my submission code. I'll take a look at it. I have some setup for my 0 page. And then I load the character sets, the characters in from the character set. And that was one of the things that I learned that I didn't have to do, because I loaded all the characters in to memory somewhere. And then the program looped through those. And then the top entries, what they did was they loaded one character at a time in, and they didn't worry about copying it over somewhere else, because that takes up cycles and bytes. And that's something that I learned. And then I have a little program here that drew the first line right here, draw the first line, move over 8, draw the second line, move over again, draw the third line. And if we look, the way I implemented to go to the next row, I was adding 40 to the first line I was drawing and then the shadow line. And what I realized, of course, when I saw the top entries was, oh, I could have done that differently. I could have just used an index, comma, X, and then added 40 to X. And which I had contemplated doing it that way. But in my mind, I did 40 times 8, and that was 320, so it would be bigger than 255. And that was that was one of my big mistakes, was because, yeah, 40 times 8 is 320, which is greater than 255, so I can't use the X register in that example. And then even if it was 40 times 7, that was still too large. That was 280. If you think about it, let's look at the character set again, the character editor here. If you think about it, it doesn't use this bottom line, so you really only need to go 0, 40, 80, 120, 160, 200, 240. So I could have done it that way and saved a bunch of bytes. And I didn't learn that, of course, until the end. I realized my mistake. And then the other thing that I could have done would have been really simple here. So when you're drawing you draw the first letter, I have to add 10 to my offset to get to the second letter, and then another 10 to get to the third letter to start drawing the third letter. And that's what this bit of code, or this bit right here is doing, is adding 10 to that X position. When I realized the top entries, what they were doing was just storing the low byte of the position and in a small table so that they could just pull that in, and it saved them cycles and bytes. So those were a couple of optimizations. There was a few more than that I could have done differently. There's a lot more that I could have done differently to optimize this program. I was just happy to get it running. So let's take a look at it. And you'll notice here, it's just drawing whatever happens to be in address 2, 3, and 4. And then it's drawing white and black. Well, I didn't realize until today when I was looking at the other entries that you don't have to draw the color black. It was already formatted black on the screen. I didn't realize that when the submission code ran that Shallan gave us. It was all a black screen, so I didn't have to program that in, which would have saved bytes also. So anyway, that was my program submission. It was A9 bytes long, and it turned out to be just over a megabyte, 1 megacycle. Mine took the longest and was the largest. So anyway, I did enjoy doing that. Now I want to take a look at the other entries, the winning entries, and basically everyone else who submitted their project was basically, they were all very, very close. Before we look at the source, I wanted to look at the programs running, and you'll see why. So let's look at error jury. You'll see how it draws the characters, similar to what my program was doing, except they're not setting the color right here. I just noticed that. And then you'll notice it's not returning back, and I think that's because they're assuming a few things in the submission code. It runs fine when you run it with Shallan's submission code. And a lot of the programs do that. Here's Acmafin. Looks identical. Carl Henriks, he had one of the best solutions, or if not the best. And you'll see it's only drawing the number 1, but it works fine on this submission code. Endurion. His is weird. I'm not sure why it draws like that, but you do see the character in a shadow. So I watched it on stream and it drew fine with the submission code. Here's Gareth. Similar to Carl Henriks, draws that third letter. I think they must have a similar algorithm, although it's weird how it drew like a green color. Gihofs. And then his leg just crashes at the end, and I think it's making some assumptions, but all these programs ran fine on stream using Shallan submission code. That's another one, same sort of algorithm. Which gear storm. We'll take a look at mine. I already showed you mine. I'll run it again. Mine might be the only one that you could actually run it and it returns back to the prompt. And you can run it again. Just scroll it down. And it runs again. And it has the proper colors as indicated by, required by the instructions. And here's Jespers. Also, kind of, you see it flash, it displays something and crashes. Kelsos. Very similar to the one we just saw, except it's weird how the shadow is offset. It ran. LAX. Lax. Must be using a similar algorithm. It does return back, but it prints out this function var. Mine was doing that too until I had to tighten it up a little. My Gamer 68 or MV Gamer 68. Another one with the green colors. Old School Coders. His does the displays, also looks like some of the other entries. And then a Skunk Monkey. Very similar to OSKs. And ZZ. And you don't see anything. So anyway, that's how they all run. If you ran them standalone, these all got imported into C000, and when Shallan was running and writing down everyone's totals. Now looking at the program code, we'll I only have the 10 that Shallan posted on his download zip, so I don't have everyone. So we'll take a look at everyone's here, just in order here, I think alphabetically. This is Carl Henriks, and his was one of the top 3. Everything fits on the same screen, and you can see all the different techniques they use, including what they call illegal opcodes if they're in use here. I don't see any though on this one. Oh, SAX right here. He's doing one. And it's interesting just to look at this code. Some of it, you may not even, there's some different techniques. One of them was, instead of setting a value of address 1, you just do an LSR 1, which does essentially the same thing to shift out so you can grab the character ROM. And then ROL it back once you get your character. That saves a few bytes. Just little techniques like that you'll learn from these competitions when you see other people's solutions. And then here's Endurons. And I love looking at these and seeing what I can glean from them. They're very, very interesting. And I haven't really taken the time to fully absorb all of everyone's solutions, but everyone's different program styles and their the way they comment and everything. It's neat just to see how other people do things. And some of the people that worked on this for quite a long time. So it might look like just a short piece of code, but some people put hours and hours and hours. Here's Gearstrom's. Lots of notes and program code. So what I'll do is I'll put, as commenting, lots of comments. I'll put this code up on my GitHub so you can download and take a look at and compile it yourself if you want. Again, my program code very sparse, longer than everyone else's, and has very few comments. I guess I didn't put enough effort into it. And if I had spent more time and thought about it a little more, I think I could have came up with a better solution. Here's Kelso. Interesting how he indents right here. I like that. It's a nice technique to kind of show this is a certain section that's doing a certain thing, a loop perhaps. Very well commented. Lax, a little bit looks like mine, except way shorter and succinct. OSKs. He's our professional coder here over on Twitch and YouTube. And I'm going to talk to him about his program here. I'm going to try to interview him, see if I can get him to talk to me about, because he went through, according to this is his 8th attempt. So before he got to here. So he put quite a bit of time. He said he was accused of sandbagging in the last competition because he came in, I guess, last, and he didn't want that to happen, and that didn't happen this time. And here's Shallan50Ks. It's really interesting. I guess this was for byte count purposes. He was putting the bytes over here on the right for comments. And ZZ, really short and succinct. Now I want to show you, now that we've looked at everyone's source, I'm going to show you what the standings were and who won. All right, here are the standings for the May 2021 Commodore 64 monthly competition. You can see Carl Henriks' entry up at the top here with the lowest cycles. It's sorted here from top to bottom, the fastest to the slowest, or first to last, with 251,375 cycle bytes. Then ZZ with 255. You know, and I kind of wonder if you ran the averages here. So what they did was they ran the program 3 times, averaged them, and then did the math over here on the right. But I've noticed when I was running the test that sometimes the numbers would come up lower, sometimes they would come up higher, and so it was kind of the luck of the draw. And I sort of wish that Shallan would have, instead of doing random characters, would have, for the final counts, would have used fixed characters like ABC or 1, 2, 3 or something like that, so that we could really get a good idea of not just a random cycle count, but running the exact same code, whose was actually the fastest. Carl also mentioned on the chat that he had a 71 byte version, and he did a blog post, which I will link. It's a very, very good blog post, completely detailing his entry, and it's amazing. So I will link that, and it's highly recommended you check that out if you're interested in this type of stuff. The next one was ZZ with 255,275. Then Gearstrom, you can see how close, 256, 855. Lax with 296, 863. Kelso, 297, 573. Jesper, 331, 740. Now the reason why his was marked in red was he was disqualified because his shadow wasn't displaying properly. So he had some sort of a bug in there, but if you're looking at it, only 90 bytes, very low cycle counts. I think it was a minor issue, but unfortunately it was disqualified. Then Gareth with 85 bytes, 338,187. Skunk Monkey, 92 bytes, 339. Gihaf, 84 bytes, 366. Akmafin, 98 bytes, 480. MV Gamer, 104 bytes, 522 on the cycle bytes. Enduron, 120 bytes, 556K. OSK, 122 bytes, 601K. Air Jury, 123 bytes, so really close between these last three. 720 cycle bytes. And then mine, the lowly 170 bytes, and 1 mega cycle, basically. So anyhow, those are the results of this competition. I hope you liked this video. If you did, please like and subscribe, and thanks for watching.